Well, hello, this is Chapter 7, Section 4, Quadratic Functions. We are going to do a couple examples similar to what you're going to do in class and for homework for the next couple days. While I do this, I'm not going to point out every single clue to you. I want you to try to figure out patterns between the functions themselves, the inputs and the outputs, and the graphing. Alright? So the first thing you need to write down is that the greatest the exponent of the variable can be is 2. Remember, you can pause this video at any time you need to. Some of you might be a little lost right now, but there's our variable and there's our exponent. And there's our constant. So our quadratic function is y is equal to x squared plus 1. Let's make ourselves a t-chart. I am going to be creating the same pattern I usually do on my inputs, which is 2 positives, 0, and then 2 negatives. If you feel like being more creative when you do your homework, go right ahead. And now it's just a matter of ourselves putting these inputs in for x, solving each function 5 times, and then we'll have 5 different outputs. So y squared is equal to the quantity 2 squared plus 1. 2 squared is 4 plus 1, which is 5. So when we put 2 in, we get 5. Here we go for 1. Y is equal to the quantity 1 squared plus 1. 1 squared is 1. 1 plus 1 is 2. We're just basically practicing fundamentals. Y is equal to, this time we're putting 0. I think we can say that we know that 0 squared is 0, 0 plus 1 is 1. So we're just going to jump to that one. D y is equal to the quantity negative 1 squared plus 1. Negative 1 squared is positive 1, plus 1 is 2. Now you'll notice something with the x and the y input and outputs. Here comes e, the last one. Y is equal to the quantity of negative 2 squared plus 1. The quantity negative 2 squared is positive 4, plus 1 is 5. So hopefully you notice that each x we've solved was different, but pay attention to the y's. We have some repeats. So now let's graph this as well as we can. So our x's are 2 to negative 2, and our y's are from 5 to 5. So let's see. Our y's 5, 4, 3, 2, 1, 0. This is my x-axis. Here's my y-axis, the y here. This will be 1, 2, 3, 4, and 5. I'll put a negative 1 here just so we have scale. This will be positive 1, This will be positive 2. This will be negative 1. And this will be negative 2. So when we put 2 in, 1, 2, we get a 5. 1, 2, 3, 4, 5. That's A. When we put a 1 in, 1, 2 is the output. 1, 2. That's B. When we put 0 in, the outcome is 1. When we put negative 1 in, the result is a positive 2. And the final point, the input of negative 2 gives us an output of positive 5. This should not be graphed as a letter V. This is going to have a curve to it. Usually the first thing I do is I put sort of like a dome, whether it's concave or convex. I put a dome there. This is going to have curve to it. And there you go. That is your quadratic function. I want you to think about that and compare that to our linear functions of last week. Just pay attention to the way what the function says. Think about linear functions from last week. This is a quadratic. Linear functions were lines, right? Straight lines. Diagonal, horizontal, vertical. These are not lines. These are something else. And we've talked about what they're called. Now let's see if you can think about that one in your head. I'm going to turn my paper over. And we're going to go into the second example. This one will have a fraction. So y is equal to x squared over 3, or divided by 3, minus 1. So what I'd like you to do is think about what the multiples of 3 are, and that would really help us out in terms of just getting through this sort of easy. My positive multiples of 3 that I would like to use are 6 and 3. I always want to use 0, and my negative inputs would be negative 3 and negative 6. And here we go. Y is equal to 6 squared over 3 minus 1. 6 squared is 36 divided by 3 minus 1. 36 over 3 is 12. 12 over minus 1 is 11. So an input of 6 gives us an output of 11. Here comes B. This is the other positive. Y is equal to 3 squared over 3 minus 1. Just so you know, you do have an option. Instead of actually doing x or 3 squared, you could write 3 times 3 over 3. So we've expanded our exponential form. And then you can simplify 3 over 3, and that leaves us with 3 over 1, which then gives us 2. So an input of 3 gives us an output of 2. You could have done this exact same method over here with the 6's. Would have been similar, but not exactly the same in work. Alright, our third point is 0. Always like working with 0. Okay, 0 squared divided by 3 minus 1. 0 squared is 0. 0 divided by 3 is 0. And finally, 0 minus 1 is negative 1. Comes D. This is the negative 3. Negative 3, the quantity negative 3 squared divided by 3 minus 1. That's going to be positive 9 over 3 minus 1. 9 divided by 3 is 3. Minus 1 is 2. We had an answer of 2 earlier, didn't we? Pay attention to your outputs as we go down the Y list of the T chart. And then finally E. This is the negative 6. Y is equal to the quantity negative 6 squared over 3 minus 1. This time I'll expand this one. So this is negative 6 times negative 6 over 3 over minus 1. Now what I'm going to do here is 3 goes into 6 negative 2 times. Negative 2 times negative 6 is positive 12 minus 1. And that gives us an answer of 11. And if you remember, up here we had an answer of 11. So there's our T-chart. Negative 6 in, 11 out. So now I'm going to graph a table for this. Let's see. We're going to have to skip numbers, so our interval is going to be 2. This is my x-axis down at the bottom of the page. And I'm going to go by ones, or I'm going to start with 1. This will be 3, 5, 7, 9, 11. That'll be 13. So again, 1, 3, 5, 7, 9, 11, 13. My x-axis is going to be 1 and 3, negative 1, negative 3. 5, 5, and this will be our negative 7 or positive 7. Okay, so we're good. So again, this is 1, 3, 5, 7, negative 1, negative 3, negative 5, negative 7. I'm going to graph this real quickly. 6, 11. So I'm going to go across 6, which would be between the 5 and the 7. I'm going to go up here to 11. This is A. B is 3, 2 over 3 up 2. Zero, negative 1. 0, negative 1 would be actually right here at the line. I should have dropped it a little bit farther, but it'll be okay. Negative 1, I'm sorry, excuse me, negative 3, positive 2. Negative 3, positive 2. And then finally, negative 6, negative 11. And again, you don't want to make this the letter V. It's going to have a curve to it. And there you go. That's your... There was a word I was asking for, but I'm going to give it to you because I think you have it. That's our parabola. And this parabola is positive. I want you to pay attention to all the little clues that you should be looking for. Like, where is this point in our parabola? Is it below the x-axis? Is it above the x-axis? Pay attention to the quadratic function itself and see if there's a clue that can help us with that. Alright, well, use this to help yourself during the notes. Good luck.